Hey class, in this video I'm going to work out the examples that I had on the area and perimeter PowerPoint. I did some of these in our Zoom session this morning, but I just wanted to go back and record these examples so that you would know how to do them. This is the area and perimeter formulas that I want you to memorize. You should probably be familiar with most of them. In this example, this is finding the area of an irregular shape. The whole purpose of a question like this is to partition the shape into regular size shapes. So for example, this entire piece right here is 4 units. You can also draw a line right here, and here's 1 additional unit, and here's 1 additional unit, and then here is 1/2 and 1/2. You can also look at this as a triangle. Well, it is a triangle, and you can say base times height divided by 2. So 1 times 1 divided by 2 is how you get the 0.5. Add them all together. This is 1/2 plus 1/2 plus 4 plus 1, and that's a total of 6 square units. Okay, we also did this one in class. So I'll just go through this one quickly. The same concept as before, you're just splitting the shape into shapes that you recognize. So this would be 11 by 16 is this rectangle. 11 times 16 is 176 meters squared. And then to figure out this top portion, we know that this is 7. And do you see if we extend this 11 that it would match up with this 18? And so if the whole piece from here to here is 18, part of it is 11, the other part must be 7, and so that section must be 7. 7 times 7 is 49 meters squared, and then you are going to add those together to get 225 meters squared. Okay, take a look at this one. We did not have time to do this one. Here's how I'm going to approach this problem. I'm going to go ahead and just draw the top line. And so now do you see that we have a square that's 15 times 15? The area of the square is 15 times 15, which is 225 meters squared. Now this part that I'm coloring in green, that is not part of the original shape. So do you see that if we take the area of the square and subtract the area of the triangle, that will give us our answer? First, we know that this is 15 meters, and then how would we be able to find that height? Well, if we know that this height is 15, we know part of it is 8, and that means this part is 7. Now, I realize this picture is not drawn to scale, but the math works out. 15 minus 8 is 7. We also know that the area of a triangle is base times height divided by 2. 15 times 7 is 105. Divide that by 2 to get 52.5. So the triangle is 52.5. Now I want you to do a subtraction problem. 225 minus 52.5, and that gives you a total area of 172.5 meters squared. Okay, we did this one in class, but I'm going to go ahead and rework it. The given information is that the swimming pool has a radius of 15 feet and the deck is 3 feet wide. We're going to find the total area, and this is the deck and pool, and then we're going to subtract just the area of the pool. Total area, if we know the pool has a 15-foot radius and then there's an additional 3 for the deck, so the total area is going to be 3.14 times 18 times 18, and that's 1,017.36. Now we're going to find the area of just the pool. It's 3.14 times 15 times 15, and that is 706.5. Now subtract those two values to get 310.86 feet squared. This one talks about Tim. He's going to re-tile his living room floor. This is the dimensions of his living room, 30 feet by 14 feet. And then the tiles are these 3 by 3 inch squares. The first thing I want you to do is convert the dimensions of the living room from feet to inches. So we're going to do 30 times 12 and then 14 times 12. 30 times 12 is 360. And 14 times 12 is 168. So those are the dimensions of the room, 360 inches by 176 inches. We are going to multiply those together to get 60 60,480 inches squared. This is just the living room space converted into inches. Next, each tile is 3 by 3. So each tile takes up 9 inches squared. We have a total of 60,400 inches squared, and we want to know how many tiles fit on that floor if every tile is 9 inches squared. So we're going to do a division problem. 60,480 divided by 9, 6,720 tiles, except the question asks, how many boxes of tiles does Tim need? There's 24 tiles per box. Tim needs a total of 6,720 tiles. So I want you to do one more division problem. 6,720 divided by 24 per box to get a total of 280 boxes. Okay, the figure shows 4 circles, each with a radius of 5. Find the area of the region between the circles to the nearest hundredths. Okay, the first information that we know is that each of these have a radius of 5 centimeters. Okay, since it has a radius of 5, we could also draw the radiuses like this so that they touch, and then 5 plus 5 is 10. So let me erase this and redraw this, because what I'm trying to get to is that there's a square by connecting the radiuses together, and this square is 10 centimeters by 10 centimeters. So first, the area of the square is 10 times 10, which is 100 centimeters squared. Okay, now we need to find the area of the shaded area here in this grayish area. But do you see that what we don't want to include is this quarter of the circle, this quarter of the circle, this quarter, and this quarter? Also, do you see that those 4 quarters equal 1 whole circle? And so what we want to do is we want to find the area of one of these circles, because each of the circles are the same. And so when you add these 4 quarters together, you will get 1 whole circle. Okay, so the area of a circle is pi r squared. This is 3.14 times 5 squared, which is 78.5. Next, I want you to take the area of the square and subtract the area of the circle, which is really the 4 sections of the circle, the quarter sections, which equals 1 total, and you should get 21.5 centimeters squared. The answer may be slightly different if you use the pi button on your calculator instead of 3.14, but your answer should be close to 21.5 centimeters squared. Okay, that's all for this video. If you have any questions, please let me know. Hopefully this has helped, and I will see you later on Zoom.